Good day and thank you for joining our session. Today what we will be looking at is a very important topic which you will carry with you till the end of your high school career. So, looking at what it is, it will be straight line geometry. So before we get into the bulk of the content, I want you guys to try and get an understanding of basically some very important principles and some terminology as well. Okay, so as you can see right here, I have a straight line. Okay, so we all know that a straight line is equal to 180 degrees, right? So this is 180 degree angle here, right? But what happens if this angle is cut by another line coming through it like this? Okay, so as you can see now, our angle is split. Our 180 degree angle is split into two separate angles. This is the one part and this is the other part. So how do we go about finding out the size of these angles? So generally they would give us the size of one of these angles. So let's say that this angle over here was 60 degrees. So this is the angle on this side of the line that intercepted our angle. Okay, so how are we going to find out the size of that? So this brings us to the first principle, which is writing a statement. Okay, and we write our statement by following certain rules that we know, and we know that this whole angle over here is equal to 180 degrees. So this angle is equal to 180 degrees, and how we're going to turn that into a statement for our working out is we're going to say 60 degrees, and generally what we'd call this unknown angle is x. Okay, so our statement is going to be 60 degrees plus x is equal to 180 degrees. Cool. And here's where a terminology comes into our reason. Okay, so we need to give a statement as well as a reason when we're busy with these type of sums. Okay, so our statement here we saw was 60 degrees plus x equal to 180 degrees. Now we need to give them a reason why we say this statement. Okay, and the reason we're going to give them, let me just split this up quickly into two sections. So the reason that we want to give them is what we understand. We understand that 180 degrees, two angles adding up to 180 degrees is supplementary. Okay, so our reason will be, let me just put this line back in. Angles of a straight line supplementary. Okay, so two angles that add up to 180 degrees are supplementary angles, and we know two angles on a straight line will add up to 180 degrees because we know that a straight line is equal to 180 degrees, right? So here we have our statement, 60 degrees plus x equal to 180 degrees. Angles of a straight line are supplementary. So now we can find our answer, right? So basically we'll just be solving for x. We'll keep the x on this side. We'll have 180 degrees minus 60 degrees, which is going to give me a final answer of 120 degrees. So x is equal to 120 degrees. So we found out the value of x, the unknown angle over here. So now we have our good old 90 degree angle. And what do we know about a 90 degree angle? It is equal to 90 degrees. Obviously it's a right angle that's equal to 90 degrees. So what happens when they cut this angle? Let's say they cut it like that. So let's say they cut it like that, and they give us one of these angles as, once again, 60 degrees. But now they want us to find the size of this angle over here, and what do they call it? They call this angle x. Cool. So now we need to come up with a statement. We know that this angle is equal to 90 degrees. So the way we're going to write out the statement is we're going to say what we know. We have 60 degrees and the other angle which is there, which should be adding to 90 degrees, is x. So we know that 60 degrees plus x will give me 90 degrees. So we've given them our statement. Now we're going to give them a reason as well. Our reason is going to be that angles of a right angle are complementary. So a little bit of understanding of the meaning of complementary. That is when two angles add up to 90 degrees, and we know a right angle is equal to 90 degrees. So these two angles are complementary because they add up to 90 degrees. Okay, so now we'll solve for x again. We'll keep x on this side, and we'll have 90 degrees minus 60 degrees, because remember we have to bring the 60 degree over to the 90. It turns to a negative, so we'll have x is equal to 30 degrees. Now we're going to look at this shape that we haven't really seen before. It is an x, right? We can see that two lines are crossing over each other to make an x. So we left with one angle over here and another angle over here. So we're going to stick with our value that we've been working with this entire time, and we're going to say that this angle over here is equal to 60 degrees. So what do we say about angles that are basically opposite from each other, right? You can see this x forms on the one side of these two lines is 60 degrees, on the other side of the two lines is an angle that we do not know, x. So basically this is a rule that we're going to learn now that tells us that these two angles are equal. So we'll say these two angles are equal. X is equal to 60 degrees, and the reason is because they are vertically opposite. So this is the new rule that you guys are learning now, is that when there is an X formation like this and we have two angles that are opposite from one another, the angles are equal because the rule is vertically opposite angles. Okay, so that will be our reason. So a very important thing we always need to know, that when we're dealing with straight line geometry, we are always going to have a statement, and then we are always going to have a reason. Okay, so now we can move on. So this is going to be a very important principle that you guys are going to have to follow when working out straight line geometry questions. Okay, so this is going to help you understand the mechanics behind it. Okay, so we call it fuzzy X. What does this mean? Okay, so let's have a look. I'm going to show you the different principles which apply to each letter. So if we look at the F, I'm going to show you where the two angles are that apply to this rule. So we're going to have an angle over here, and we're going to have an angle over here. Okay, so if we see in a structure that there's an F forming with the lines, we can say that there's the angle over here and the angle over here are equal. So these two angles will be equal. Okay, and the rule that we have for this is that these angles are corresponding angles. Okay, so corresponding angles are equal to each other. Okay, but what if the line also went up? Let me just find a nice size to do this quickly. Let's say the line also went up further, right? Sorry about the thickness, but we're going to work with it. If the line continued up, you could also say that the angles that are opposite from one another, in this case being on top of the line, right? So there's still a F, but we're just dealing with the angles on top of the line, right? These angles will also be equal. But now a very important thing to understand is that this rule can only apply when we're dealing with parallel lines. Can you see? So these lines are parallel, right? So the two angles above the parallel line are equal, and the two angles below the parallel line are equal as well. Okay, and this is in the F formation, so they are corresponding. Now let's see. This rule over here with the U also deals with parallel lines. So what angles are we going to be looking at? We're going to be looking at the angles on the inside of the U. So what is the rule here? The rule is that these two angles added together will give me 180 degrees. So this is equal to 180 degrees. So this angle plus this angle equals 180 degrees. And the rule, what we call it is co-interior angles. Cool. So we had corresponding angles with the F formation and co-interior angles with the U formation. So now we move over to the Z. Now again we are dealing with parallel lines. And what do these parallel lines tell us? The two angles that we will be dealing with are the two angles that are inside the arc of the Z, okay? So you can see the one arc is going to be this over here, and the other arc is going to be this over here. So these angles are on the inside of the arc, right? So what does the rule say about these angles? It says that these angles are equal to one another, okay? And now remember, the fact that there are parallel lines is very important. If there is no parallel lines, this rule cannot apply, okay? So because these lines are parallel, these two angles are going to be equal, okay? So if we see lines forming a Z formation, we know that if there are parallel lines, that the inside angles are equal. This rule is going to be called alternate angles. Now we're going to look at the Y over here. Now we've already worked on an example like this. It is basically the straight line rule that we just covered. Okay, and that is where two angles are supplementary. They add up to 180 degrees, okay? So we know that this angle plus this angle over here, okay, they are going to add up to 180 degrees. And we're just going to write in the rule here again, supplementary angles. Then we look at the last formation here, which we've dealt with already as well, is with the X formation, where these two angles are equal. And we've already said that this rule is vertically opposite angles. It's very important to note also, it doesn't matter about the orientation of the F, the U, the Z, the Y, or the X. The F could be upside down, the U could be to the side, the Z could also be flipped 90 degrees. It doesn't matter, as long as we can find the shape, there is an answer there, okay? So looking at an example here, we're going to try and look for shapes to solve for the various numbers over here. So we have 1, 2, 3, 4, 5, 6, 7. Okay, so let's try and find number 1 first. Okay, let's see. So if looking at number 1, we're going to first have a nice area here that we can work with. So let's look at number 1. We try and solve for 1 we can say is equal to, so you can see here that we have 110 degrees. So let's look at this as a straight line. We have a straight line running here, right? And we have 110 degrees on the one side. As we can see, 1 is on the other side. So what do we know about a straight line? It's equal to 180 degrees. So we can say that this angle over here, which we'll call 1, angle number 1, so we'll put the angle above it, angle 1 plus 110 degrees is equal to 180 degrees. Cool. And our reason, remember that's our statement, and our reason is going to be angles on a straight line are supplementary, right? So let's see now if we can find the angle that is number 3. Let's try number 3 first, okay? So angle number 3, what other formation can we see? Let's say we take both of these lines that cross over each other. We can see that there's an X, right? So you can see there's a lot of shapes hidden over here. You've probably spotted a few others, but let's see, we can see the X, right? You can see it's flipped a bit. So angle 1 and angle 3 are opposite from one another, right? So what can we say? We can say that angle 3 is equal to angle number 1, right? So if we say that angle 3 is equal to angle number 1, which is equal to, so we didn't solve for angle number 1 here, so let's do that quickly. We'll say angle 1 is equal to 180 degrees minus 110 degrees, which is going to give me 70 degrees, right? So that means that angle number 3 will also equal 70 degrees, right? So we can say that the reason is because these angles are vertically opposite. So we can write it shortened as vert op. Okay, vert op angles. So these are vertically opposite angles. So let's just write in the answers that we do have so far. We have that this is 70 degrees, we have that this is as well 70 degrees, and since these are opposite each other in an x, wouldn't 2 also be opposite 110 in an x? If you think so, you'd be correct, right? So we can also say that angle 2 is opposite obviously 110 degrees, so it will be equal to 110 degrees, right? And the reason is vertically opposite angles. So now we've already solved for the first 3 angles over here, so we'll just put in, sorry, it's 110. It's 110 degrees. So now we need to try and figure out how we're going to get down over here. So I'm not sure if any of you have seen it, but there is a formation in the shape of a Z, right? Can we see that? And what do we know about the Z? That is the alternate angle rule. So if we're going to look for our alternating angles, remember it's on the inside, so that means that's angle number 3 and angle number 5, which are on the inside. Now remember, we have to look for parallel lines. As we can see here, these lines are indeed parallel, so therefore we can apply the alternating rule. Alternate angles are equal, right? So we can say that angle number 3 is equal to angle number 5, which is equal to 70 degrees. Cool. Now that's our statement. We give our reason. Alternate angles. So guys, a very important thing that I forgot to mention now is that when we're dealing with rules that apply to there being parallel lines, as you can see here, alternate angles, they rely on 2 lines being parallel. We'll say which lines are parallel. So we say AB is parallel to CD. I forgot to mention that earlier when we were going over the parallel line rules of fuzzy X. Okay, so we've identified that these 2 angles are alternate, so we'll say in our reason which 2 lines are parallel. So now that we've gotten that out the way, we can write in that this angle over here is equal to 70 degrees, right? So let's find another way to solve for angle number 4. I'm just trying to fit in as much reasons as we can so you guys can get an understanding of it, okay? So we can see here that there's another formation here of another letter, which is a U. And remember now, the U also requires parallel lines, and we've already seen that these 2 lines are parallel. So what is the U formation? If you said it was co-interior, you'd be correct. So looking at the co-interior rule, we know that 2 angles are supplementary. They need to add up to 180 degrees. Cool. So what we're going to do is we're going to say that 70 degrees plus angle 4 is equal to 180 degrees. Our reason we're going to give is co-interior angles, right? Because the U rule is co-interior angles. Now you can see that we could have done the straight line rule to find this angle. That is another way. So you can see there are many ways to find these different angles, okay? So if you can't find it one way, try another way and maybe it works better for you. So now we're going to solve for angle 4. 180 degrees minus 70 degrees, because we brought that 70 over, it became negative, So therefore our final answer is now going to be 110 degrees. Awesome. So now how are we going to solve for angle number 7? Let's see, we're going to clear up some space after this one. Angle number 7, right? So we can look at for another formation forming, and we can say that here is a reverse F. So you can see the F can also be reversed and relies on parallel lines, which we do have. Okay. So one thing I forgot to also put in is that, remember, co-interior angles rely on parallel lines. We have to always state which two lines are parallel. So AB is parallel to CD. Cool. So now moving back onto angle number 7, we can see that we're dealing with angles that are underneath, right? Angles that are underneath the parallel lines. So angle 3 and angle 7 will be equal. Correct? So angle 7 is equal to 70 degrees. And our reason is going to be corresponding angles. Cool. So let me just clear up some space here on the top. So we can work out our last one, which is going to be angle number 6. Let me just write in our answers for angle number 4 and 7. Angle number 4 was 110 degrees. Angle number 7 was 70 degrees. So now we can just use the method that we've used before. We can use the X, and now we can just say that angle 6 is equal to angle 4, which is equal to 110 degrees, and the reason is going to be vertically opposite angles. And coming back here to the corresponding angles again, remember the corresponding rule relies on parallel lines. So we need to write in AB is parallel to CD. Cool. So as you can see, we've tried to use as much of the rules that we've just learned in this one example. I hope you guys could understand, and thank you for joining our session for today.